We're going to have a look in this video at how we multiply surds together. Remember, surds are numbers in square roots. They're irrational numbers. Let's have a look at this first example. The square root of 2 multiplied by the square root of 3. Now, from our previous video on surds and our work with the rules of indices, we know that we can rewrite that as the square root of 2 times by 3. Both the numbers now appearing under the same square root. 2 times 3 is 6, so actually that's just the square root of 6. 6 is not a square number, so the square root of 6 is going to be an irrational number, and that's why we would leave it as the square root of 6, root 6, which is a completely accurate answer. Root 2 times root 18. Just like we did over here, we can use our rules of indices to say that that is the root of 2 times by 18. 2 times 18, of course, is the square root of 36. Unlike here, we do actually have a square number in here now, so we can evaluate, we can take that square root. The square root of 36 is 6. So it's really interesting to notice that when we multiply two irrational numbers together, we can end up with a rational number, an integer in this case. Finally, let's have a look at this, what looks like quite a complicated example, but we're only going to use the same ideas again. We've got root 3 outside of a bracket, inside the bracket 2 root 6 plus 3 root 2. So we need to multiply each term inside the bracket by root 3. So let's do that. First of all, we're going to multiply root 3 by 2 root 6. So we're going to get 2 times by root 3 times by root 6. All I've done is reordered those, root 3 times 2 times root 6, 2 times root 3 times root 6. We do the same over here. We've got root 3 times root 2. Again, I'm going to reorder them to put the rational number first. 3 times root 3 times by root 2. Okay, so now let's tidy up a little bit, just like we did here. When we're multiplying two surds together, we can say that is 2 times by the square root of 3 times 6, which is 2 times root 18, plus 3 times the square root of 3 times 2, which is 6. Now that's absolutely correct. It wouldn't actually get you full marks because there is one final step that we could do on this. If you remember that we're always looking for the lowest possible number inside the square root to put the surd in its simplest form. And 18, of course, is 2 times 9. So we've got a square number there of 9. So if we said that is 2 times by the square root of 9 times by 2 plus 3 root 6 equals 2 times the square root of 9 times the square root of 2. Square root of 9, of course, is 3 times by the square root of 2 plus 3 root 6. Finally, just tidying up, 2 times 3 is 6. So we have got 6 times root 2 plus 3 root 6. That would get the full marks because the surds there are in their simplest form.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.